Okay, so first of all, do not freak out because you have 3 pieces of paper in front of you. We're not doing every single example, and it will be fine. This is going on page 147 when we are done. So we are starting a section on sequences and series. We're going to start with sequences, so I'm going to give you the definition of a sequence first. It is a set of numbers with a particular order or pattern. Okay, so a set of numbers with a particular order or pattern. Each number is a term. Okay, so we're going to have terms in our sequences. 2 different kinds. We have finite and infinite. So infinite is pretty much just what it sounds like. Finite would be the opposite of that. So a finite sequence is a sequence with a limited number of terms. Or a number of terms that you can actually count. So an example would be 1, 2, 3, 4, 5. An infinite sequence would be a sequence with an unlimited number of terms. Okay, an example would be 1, 2, 3, 4, 5, 6, 7, ... and go on for infinity. Okay, so there's your sequences. A lot of times these would be like the patterns, you know, which term comes next and how could you describe the pattern, that sort of thing. So let's talk about notation. Notation is very important in this so you know what you're reading and how to write it correctly. So our term notation, the first term in a sequence is denoted as a sub 1. Each subsequent term, which means each one after that, is denoted as a sub n plus 1, where n plus 1 is the term number in the sequence. Okay, so here's an example. We are given 2, 5, 8, 11, and 14. We want to identify the following terms. So the first thing, since we're going to have to go all the way to 14, we only have 1, 2, 3, 4, 5 terms, so we need to get the rest of what we need. We need to identify what's happening. We're adding 3 each time, so to continue this would be 17, and then 20, and then 23, 26, 29, 32, 35, 38, 41. All right, so A1, the first term is 2. A5 would be 1, 2, 3, 4, 5 would be 14. A8, 1, 2, 3, 4, 5, 6, 7, 8 is 23. And A14 is 41. Okay, so that's your term numbers. It's the number of the term in the sequence there. We can look at sequences as functions. Okay, so since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers. Okay, so term number 1, 2, 3, 4, 5, that's your domain. And then the range is the set of term values. In an infinite set, the domain is the set of natural numbers. Okay, spell that right. So 1, 2, 3, 4, all the way to infinity. Okay. We can come up with formulas for these. So like once you see a pattern, whatever's happening, you can turn it into a formula. I'm quite sure that is something that you did in Algebra 1 when you were reading or writing equations. you can do this in a couple of different ways. The first thing we're going to talk about is a recursive formula, and that's kind of just something that would describe it, but the problem with these is that you have to know the terms leading up to the one you want. And so you may not want to write out 50 terms or whatever it is you need. So a recursive formula is a rule in which one or more previous terms are used to generate the next term. So one very common example of that is the Fibonacci sequence. So that is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Okay. So when you have a recursive formula, you have to set at least A1, sometimes more than that. But in this, if I'm going to say A1 is 0 and A2 is 1, and then if you look at what's happening with this pattern to get the next term, like how do I get 8 from 5? Well, I add 3 to it. How do I get 5 from 3? Well, I add 2 to it. How do I get 13 from 8? I add 5 to it. So you add the 2 previous terms to get the next term. So in order to do that, if whatever term I want, in order to get it, I'm going to have to add the term before it, which would be a sub n minus 1, because if this is a5, this would be a4, plus the one before that, which would be a n minus 2. Okay, so the term number, whatever a5 would be a4 plus a3. You add the 2 terms before it to get that one. That's what a recursive formula looks like, which means that to get the 500th term, I have to know the 499th and the 498th. So I don't necessarily want to write all those out, and there could be a different rule that I write to come up with that. So here are some recursive formulas. Okay, this is recursive because we have identified the first term and what's happening with this, and I want to give the first 5 terms in this. So in order to do that, A1, well, A1 is 25, okay? Then that's 8, when I want A2, 2 minus 1 is 1, so I take A1 and I subtract 7 from it, so I get 18. And then I subtract 7 from that, and I get 11. Subtract 7, I get 4. Subtract 7, I get negative 3. There are my first 5 terms. This is written right here because this rule only works if n is greater than or equal to 2. Since I have set what 1 is, if I substitute in 1 here, this gives me a sub 0, and I don't even know what that is. So this only works when n is greater than or equal to 2. Now remember, when you're doing this, these are my first 5 terms. Here, n equals 1, n equals 2, n equals 3, because those are the term numbers, right? 1, 2, 3, 4, and 5 is the n's, and then those numbers themselves are the actual term values. Right? So let's flip it over on the back. And I want to look at number 4. Okay? So number 4, we have set what A1 and A2 is. And then this is my recursive formula, but since 1 and 2 are both set, that's why n only works when it's greater than or equal to 3. And I'm still looking for the first 5 terms here. So term 1 is 8, term 2 is 10. That's great. Well then, to find the rest of them, to find the third term, I'm going to take 3 minus 1, that's the second term, over 3 minus 2 over the first term. So I would take 10 and put it over 8. So when I put 10 over 8, that's going to reduce to 5/4. Then I'm going to take 5/4 and put it over 10. So 5/4 divided by 10 is the same thing as 5/4 times 1 over 10, which is going to give me 1/8. And then when I take 1/8 and divide it by 5/4, it's going to be 1/8 times 4/5, which gives me 1/10. Okay, so there are the first 5 terms there. That's how recursive formulas work. Now we need to be able to write a recursive rule as well. So we have to be able to not only use them, but to write them. So to write them, you want to ask yourself, okay, so what's happening? Like, how would I describe this pattern? Well, here I add 4, and then I add 4, and then I add 4, right? When you write a recursive rule, you have to say, all right, I'm going to take the a sub n is equal to the term before it plus 4. But I have to have a starting point, so I have to identify a1 as being 9, so I know where to start. And then because I've identified what a1 is, n has to be greater than or equal to 2 for this to work. Okay, so here's my recursive formula. And then it also said to find a8. So in order for me to do that, I have to keep going 1, 2, 3, 4, 5. So I add 4, I get 29, 33, 37. So a8 is equal to 37. Now let's look at what is happening in number 6. So I want you to pause the video. I want you to see if you can think about what the pattern is, like how would you describe to me what is happening with the pattern, and then unpause it. But just like before, I am not stopping when I tell you to pause it. I'm just going to keep on going. So if you don't pause it, then you're not going to have any time to think there. All right, so what's happening? Let's see. I add 2, then I add 5, then I add, I don't see that I'm adding anything necessarily that makes sense there, but if I add 1 plus 3, that's 4, it's not 8. And 3 plus 8 is 11, not 22. And 8 plus 22 is 30. But if you look at what's happening there, 1 plus 3 is 4, times 2 is 8. 3 plus 8 is 11, times 2 is 22. 8 plus 22 is 30, times 2 is 60. So I could write that out a couple of different ways, but one of the ways that I could write that is to say that the nth term is equal to, well, I would take the 2 terms before it, so that would be a(n minus 1 plus a(n minus 2, and then I would, after I added them together, I would multiply them by 2. That's one way to do it, or I could, multiply them both, like distribute the 2 basically. But since I'm writing it like that, I have to identify not only what the first term is, which is 1, but also what the second term is, since I have 2 of them in here. Then that means that this only works if n is greater than or equal to 3, because I'd have to start at 3. So there's my rule. I want to find a8, so this is 1, 2, 3, 4, 5, 6, 7, 8 I need. So I'd add these 2 together and multiply by 2, and then add the next 2 together, multiply by 2. See if you can pause this, find a8, and then I'll tell you what it is. Right, a8 is equal to 1224. Okay. So that's recursive formulas. Explicit formulas are the ones that are going to look more like equations that you are used to. So an explicit formula is a rule in which the nth term is defined as a function of n. Okay. So let's look at number 7. It says give the first 5 terms of each sequence. Okay. So here's what this is going to look like. I have 1, 2, 3, 4, 5. That I'm going to fill in. N equals, this will be n equals 1, n equals 2, n equals 3, 4, and 5. Okay, remember those are my n values. So I substitute in 1. 1 times 5 is 5, plus 1 is 6. Then 2 times 5 is 10, plus 1 is 11. And then this would give me 16. 4 times 5 would be 21. 5, and that would give me 26. Okay, that's the way the explicit formulas work. Now I want you to note something here so that when we get to the next part, this will make sense. If I was to give you this and ask you to explain to me what's happening in the pattern, you would most likely say, well, I'm adding 5, right? Plus 5, plus 5, plus 5, right? So notice how we're adding 5 each time, and that number's 5. Not a coincidence there, okay? All right. then I don't think we need to do any more of those examples. The writing an explicit rule, I'm going to give you a way to do that depending on what type of sequence you have in the next set of notes, so we're not even going to worry about the rest of what's on here. I just needed to get you introduced to sequences and understand what explicit and recursive is so that we can move on and talk about specifics. So grab your next sheet of paper. It's going on, it's going on page 148. So there's two different types of sequences that we're going to talk about, arithmetic and geometric. Today we're just going to talk about arithmetic. It's like a different form of the word arithmetic. So an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. Okay. So the difference between any two consecutive terms is constant. That's where we're adding 5, adding 5, adding 5, so that common difference would be 5. Then so the common difference, the actual definition of that, is the numerical difference between any two terms. Okay, so it's the numerical difference between any two terms. The variable we use there is D for difference. Determining the common difference is pretty simple because that's just like you describing the pattern basically. So if you look at this, I'm going to be adding 8, adding 8, adding 8. So, plus 8, plus 8, plus 8. That means the common difference then is 8. And it says, then find the next 4 terms. I'm quite sure that you can add. I'm not going to worry about doing that part. But then here, to get -7 and -10, I'd be subtracting 3, subtracting 3, subtracting 3. And so my common difference here would be a -3. And again, I'm quite sure you can find the next 4 terms. I'm not going to spend time doing that. So I could have on the other paper where it said write an explicit formula. I could have had you look at one of these and try and come up with that equation on your own, but there's a little formula that works every time for arithmetic so that you don't have to, just do some of the weird things that you might do. This is what the arithmetic sequence formula looks like. The nth term of any arithmetic sequence, so it has to be an arithmetic sequence, which means it has to have a common difference, can be used finding this formula, or can be found using this formula. So a sub n is equal to d, which is that common difference, times n minus 1, plus a sub 1, where a sub 1 is the first term, and d is the common difference. So once you can do that, it's going to be a piece of cake. Let's look at number 5. It says write a rule for each sequence, then find the indicated term. So if you look at this, you can tell that what's happening here, I'd be adding how much each time. It'd be plus 6, plus 6, plus 6. So that common difference is 6, right? And if I want the 32nd term, if I can't write a rule for it, I'm going to have to write out 32 terms. I would really rather not do that. So instead I can use this. So in order to do this, I've got to know a few things. I have to know D, which is 6. I already figured that out. I have to know N, which is 32. And I have to know A1, which is 7. So then I just substitute in that formula. And it says write a rule for each sequence. So I need an a sub n rule first before I can actually find that. So a sub n is equal to the common difference, which is 6, times n minus 1, plus a1, which is 7. So a sub n is equal to 6n minus 6 plus 7. A sub n equals 6n plus 1. So there's my rule. That's my explicit rule, not recursive, because that's what the difference is there. But then I want to find A32, so A sub 32 is equal to 6 times 32 plus 1. So that gives me 193. Okay. So you can pause the video and see if you can do number 6. So number 6 here, to get the common difference, each one of these I am subtracting 11. So my common difference is negative 11. N in the end is going to be 24, and A1 is 4. So I've got to find my nth term formula first. So AN is equal to the common difference, which is negative 11, times n minus 1, plus A1, which is 4. So AN equals negative 11n plus 11 plus 4. So AN equals negative 11n plus 15. Then I need to find A sub 24. It's going to be equal to negative 11 times 24 plus 15. So A24 is equal to negative 249. There you go. Okay, it's that easy. Flip it over on the back. Now, we're going to do a few of these back here because they're kind of all asking you for different things. But it says use the information given to find the indicated value. So I'm going to rewrite our rule over here. It is AN equals D times n minus 1 plus A1. Okay, just so that we have it there. I am looking for, in this case, it doesn't ask me for an actual rule or anything like that. I only want A36. So A36 is equal to the common difference, I got that, 7 times n minus 1, well n is 36 minus 1, plus A1, which is 29. So that means that A36, well, you can actually just type that in your calculator exactly like you see it, and you should get 274. So let's look at number 10. Number 10 is a little different. It asks me for A1, and it gives me some other stuff. It gives me A22. So I know what A22 is. It's negative 156. That's equal to the common difference, which is negative 9, times n, which would be 22, minus 1, plus A1. Okay. So then this is negative 156 equals, well, this is going to be negative 9 times 21, which is negative 189, plus A1. So then I add 189 to both sides, and A1 is 33. So basically, you're just setting it up and finding, different parts, whatever it may be asking you for. Number 11 says to find D. So again, I set it up, the AN, my n is going to be 25, so I know what A sub 25 is, it's 107. That's equal to D, which I don't know, times n, which is 25, minus 1, plus 11. So I'm going to subtract 11 from both sides and get 96. That's equal to D times 24. Divide by 24, D equals 4. This one asks me for A13. All right, well, in order for me to find that, using this, I have to know D, N, and A1. Well, I got A1, I got N, it's 13. I don't know what D is, so I have to find that first. In order for me to find that, I'm going to have to use these two pieces of information and basically do what I just did right here. So negative 199 is A18, so that's equal to D, which I don't know, times N, which in this case is 17, minus 1, plus A1, which is 5. So I'm going to subtract 5 from both sides. Negative 204 is equal to D times 16. Divide by 16, or I'm sorry, where did I get 17? Oh, shoot, that's 18. Dang it. So this should be 17. I'm making stuff up. But I'm not starting over, so you're just going to have to deal with my mistake there. This should have been 18. So that makes this D times 17. and divide by 17, and D is equal to negative 12. Okay, so not my final answer because it didn't ask me for that, but now I have that so I can find that 13. So A13, which is what I'm looking for, is equal to D, which is negative 12, times N, which is 13, minus 1, plus A1, which is 5. And so again, I can type all that in that calculator, or you could make that 12 as you type it in, or you do it in your head because it's not that hard, whatever. But you get A13 is equal to negative 139. And then we're going to do one more of these. We're going to do number 13. 13, I need to find N in this case. So A sub N, whatever that might be, whatever N is negative 76. That's equal to D, which is negative 5, times N, which I don't know, minus 1, plus A1, which is negative 21. So I'm going to add 21 to both sides. That gives me negative 55 equals negative 5 times N minus 1. Now I could distribute that 5, but I don't need to. I can divide by 5 here at this point. I get 11 is equal to N minus 1, so N is equal to 12. And there you go. Now for 15 and 16, I'm asked to do an explicit and a recursive formula for each sequence. So I need some of the same information depending on which one I'm doing, so let's think about what we need. First of all, I need to find my common difference. So it looks like here I'm adding 2 each time, right? So I would say that D equals 2. A1 is equal to negative 19, right? So A sub N is equal to D, which is 2, times N minus 1, plus A1, or just minus 19. So AN is equal to 2N minus 2 minus 19. So AN is equal to 2N minus 21. So think about, is that your recursive or your explicit formula? That is your explicit one. So this is AN is equal to 2N minus 21. Recursive is the one where you just basically explain the pattern. You're adding 2 every time. So AN has to be the term before it, AN minus 1, plus 2. I have to state what A1 is. I have to have a starting point. It's negative 19. And then N has to be greater than or equal to 2. And there you go. And I'll give you the answer to 16 if you want to do it. If not, you can move on. But you would have AN, if you want to make sure you understand this, negative 6N plus 43. And then A1 is equal to 37 here. AN, A sub N is equal to A sub N minus 1 minus 6. And N is greater than or equal to 2. All right, next sheet of paper. See, I told you it wouldn't be that bad. This is going on 149. Talk about arithmetic means. So I want you to think about what mean means, right? Mean means average. And the definition, though, of an arithmetic mean is actually the terms between any two non-consecutive, that means it's not one right after another, non-consecutive terms in an arithmetic sequence. Okay, so a couple of key things here. They have to be non-consecutive, and we're talking about an arithmetic sequence. So, for instance, it says, for example, given this sequence right here, the arithmetic means between 8 and 32 are 14, 20, and 26. Now just think about what it means to be like the average. The arithmetic mean between 8 and 20 is 14, because 8 plus 20 divided by 2 is 14. But when you want, a few inside of here, basically, or, 20's in between these two, because if I add these two together and divide by 2, I get 20. But when you want more than one average in between it, or more than one arithmetic mean, it's basically just the pieces in the pattern there. Okay, so let's see how this works. Let's look at 17. It says find the indicated arithmetic means for each set of non-consecutive terms. So we've got 50 and 118, and we want to find 3 means in between them. So we've got 50. I need to find these 3 terms in between, and then it's 118. So in order to do this, I've got to look at what I have here. I have that A1 is equal to 50, and 1, 2, 3, 4, 5. A5 is equal to 118. Okay. So then I use my formula. 118 is equal to D, because I don't know what the common difference is, times 5 minus 1 plus 50. So then I can subtract 50 from both sides. That's going to give me 68 equals D times 4. So D is equal to 17 when I divide. So the common difference is 17. So the 4 terms then, I would take 50, add 17. That's going to give me 67. Add 17 to that, that gives me 84. Add 17 to that, I get 101. So the 3 arithmetic means are 67, 84, 101. Let's try 18. I want 5 means here. Starting with negative 16, I need 1, 2, 3, 4, 5, and then negative 58. So I start with A1 is equal to negative 16. 1, 2, 3, 4, 5, 6, 7. A7 is negative 58. So I use my rule. Negative 58 is equal to D times n minus, oh shoot, I know what n is. That's the whole point. Negative 58 equals D times n, which is 7, minus 1, plus A1, which is a negative 16. So I will add 16 to both sides. Gives me a negative 48 equals D times 6. And then not negative 48, good Lord. Negative 42 equals D times 6. So D is equal to negative 7. Since that is the case, then I take 16, subtract 7, I get negative 23, subtract 7, negative 30, subtract 7, negative 37, subtract 7, negative 44, subtract 7, negative 51, subtract 7, oh look, negative 58. So my answers are negative 23, negative 30, negative 37, negative 44, negative 51. And there you go. Okay. That is your arithmetic means. Now let's look at these application problems. A theater has 35 seats in the first row, 39 seats in the second row, 43 seats in the third row, etc. Write both an explicit and recursive formula to find the number of seats in the nth row. All right, so A1, first row, 35. Your common difference, each row has an additional 4 seats. Add 4, add 4, add 4. So your recursive formula then, AN is equal to AN minus 1 plus 4. A1 is 35, and N has to be greater than or equal to 2. There is your recursive formula. Your explicit formula would be AN is equal to D, which is 4, times N minus 1, plus A1, which is 35. So AN is equal to 4N minus 4, plus 35. AN is equal to 4N plus 31. There you go. All right, Ryan weighed himself at the end of each week into his new diet. The table to the left shows his weight at the end of each week for the first 3 weeks of his diet. Write an explicit rule, so I only want explicit rule to find his weight in weeks into his diet, then find his weight after 16 weeks. So I only want explicit. I still need a 1. So the first time is 256.3. I need D. So I can subtract 254 minus 256, 252 minus 254 with the decimals and all, and I will get D equals a negative 1.7. So to write my little formula here then, AN is equal to D, which is negative 1.7, times N minus 1 plus 256.3. So AN is equal to negative 1.7 N plus 1.7 plus 256.3. So when I clean that up, AN equals negative 1.7 N plus 258. Okay, so that is my explicit formula. Then I'm supposed to find what he weighed after 16 weeks. So I want A16. That's equal to negative 1.7 times 16 plus 258. Type that in, and you should get that A16 equals 230.816. Last one. On Anna's first birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send checks on her birthday, each at the same amount. At 7 years old, Anna's grandma had given her a total of $610. So at 7 years old, $610. At 18 years old, a total of $1270. How much money did Anna's grandma give her on her first birthday? So what I'm looking for really is A1. That's what I want. Here's what I know. I know that A7 is 610. And I know that A18 is 1270. So I want you to think, how many terms would this be between there? If I'm going to go from 7 to 18, and I wanted to list out all those terms, which I'm not going to, but if I did, I want you to think about how many terms that would be. Do you think it would be 11 terms? Like 18 minus 7? Think about here, if I went from 1 to 16 and listed all of these out here, well, if I start at 1 and go to 16, that's going to be 16 terms, right? If I do 16 minus 1, that's 15. That doesn't work that way. So to find N here, N is equal to the last term number minus the first term number plus 1. So 18 minus 7 is 11 plus 1. N would actually equal 12 there. Okay, so N would equal 12 if I'm going to go from 7 to 18. I need to pretend like this is A1 and this is A12, basically. Okay, so that I can figure out what D is. Because if I can figure out what D is, then I can go back and figure out what A1 is. So I'm going to use this as A1 and this is A12 to be able to figure D out using my little formula that I've been using. Okay, so A12, basically, or A18, I'm using that 1270, is equal to D, which I don't know. I'm using 12 terms here, minus 1, that's why N is 12, plus, and it's the first term that I'm using. It's not really A1, but it's the first term that I'm using, which is 610. That's why, although this is 18, I'm using 12 there. So to figure this out, I can subtract 610 from both sides. I'll get 660 equals D times 11. Then I divide, and D is equal to 60. Okay, so now I have D. I need A1. I can either use A7 or A18. It does not matter, because either one of them will give me the same answer to be able to write another one of these formulas. So I'll just use A7 because the number is smaller. It doesn't really matter. So if I use A7, 610 is equal to D, which I now know is 60, times N, which since I'm using 610, N is 7, minus 1 plus A1. So this is going to be 610 equals 60 times 6 plus A1. So 610 is equal to 360 plus A1. So A1 is equal to $250. Okay, there you go.